Thank you all for participating in this session focused about data. Wrestling with the data, I think, is a perfect title for the presentation we are going to have today. And thank you also to the people who are attending this session from remote. This is an hybrid format, so it will be kind of difficult to manage the Q&A session from remote and the presenters from remote, but I think we got used about this kind of format. So the scope of the session is to focus into the data enabling research focused on walkability and public space and pedestrian mobility in urban environments. So I think all of us, we are kind of passionate about data, but also kind of aware of the limitations in producing, collecting, analyzing data through different approaches and tools. By the way, I'm an urban psychologist, environmental psychologist, working with urban planners, engineers, ICT applications. So I think the very objective of the session is to understand different typologies of data, quantitative and qualitative, how to merge, and also how to find meaningful hints and results which could be easily understood by the stakeholder, decision maker, but also the general public. We want the results of the research to be understood by everyone. So this is the objective, and I want to introduce you the first delegate, the first speaker of the session. She is Renate Albrecher. Sorry for the the pronunciation. She will introduce you the presentation titled Pedestrian Typology, Sociological Look at Urban Walkways. And Renate, she is a sociologist. She is specialized in urban sociology, also focusing on gender inclusion and public space and pedestrian. She currently acts as scientific assistant at the Laboratory of Urban Sociology at the EPFL. And she also leads two research projects funded by EIT, focused on urban mobility and also furniture. So please, Renate.
Hello. So as you heard, I'm a sociologist, so it's another kind of data I will present you. And but you will find data. But first, before we start with data, what's important for us sociologists, so to what do data refer? In our case, pedestrian. But when you think of a pedestrian, who do you have in your mind? What do you think of? What's your image? What's the character of the person you think of? Very often it's this, what I think of. We'll see some of these pedestrian lights, these artists' photographs all over the world, which is very conclusive of the idea of the representation of pedestrians. I couldn't include all of them, but some you will see. For me, this expresses a lot what I see when I see urban sidewalks, that I think it's the one person, leisure or direct, going to work and back, apparently in good health, the person. But who is really on the sidewalks? Who are the real pedestrians? Her, him? Or her? Or this? So that's when you start to look on the sidewalks, you see this. I observed with my eyes, with paper and pencil, 9,000 pedestrians, urban pedestrians, always for 1 hour in several comparable situations, streets, and noted everything I saw in a qualitative way. Some things were already categorized before, some I just wrote down and then started after 7,000 to make categories and try, what do you see from that? And one typology I created was then concerning the freedom of walking. So how free are we when we walk? Is everybody really free to just move in between all the obstacles on the sidewalks or not? Or are there some reductions of the liberty of walking? And I found 3 typologies. So there's the one, usually it's now already thought of when we plan, or we hope at least that it's thought of. It's persons who have a problem with their body, a long-term individual constraint because of their body. Then there's a second one. You can have an individual constraint, but only short or medium term. This can be when you're, to translate, when you're had an accident and you walk like this person here with the key, or when you're before giving birth, etc. And also childhood is part of this, because it will disappear. But it's for a certain time, you have limits in your body. And the third one is that you have a healthy body, you could walk, but it's the circumstance of walking who doesn't allow you to move as you want, as you could. This can be because you have some external constraints, but it can also be another person you're responsible for, because you're the accompanying role for somebody who cannot walk, for a child or an elderly person who have problems to walk, which influences also your capacity of walking. And the third one is I tried to make subgroups. So yeah, I said already, you are going to accompany somebody or several persons, which means you always have to take care, you have to negotiate, you check around. The second one is that you have actual physical engagement. You walk, and in addition, you pull, you push, you carry, or you hold somebody or something, like on these photos. The third constraint is when you walk in groups. So I had to decide what's a group. So I observed urban sidewalks, and sometimes we can walk 2 persons beside, but nearly never 3. So I said from 3 on, it's a really constraint, and it's not easy anymore to move. And a fourth group are those who walk with dogs. It's also not so easy. There are some constraints in how you can walk and not. So this is the definition of the third typology. You find not a lot of information usually about it. And from this, the data coming from now are from this first 7,500 urban Swiss pedestrians in Swiss cities. So from all the pedestrians, I checked, and I could only note what I saw. And I can never exclude that I didn't see anything, especially when we have 500 pedestrians passing in 1 hour. It might see that I didn't see anything. So this is minimum percentages. Is about 3% had individual constraint, long-term, 5 around medium or short-term constraint, but 27 had an external or an individual constraint. So more of a quarter of those who walked. And here I counted only 1. So if somebody had several constraints, I decided for the stronger one. So that's, yeah, just to understand, because a lot of persons had several. When I go more into detail on the individual constraints, external, just to see what's the main constraint is, of course, walking in groups. Why? Because kids in general walk in groups. A big portion of kids walk in groups of 3. The next one is the physical engagement. It's really carrying, pulling, pushing, accompanying, and a small percentage is walking dogs of those who are in this 27%. Yeah, as I said, several constraints are often combined, especially women, as we had the one person who was carrying, pushing, and having a lot of kids to accompany. In all groups, age groups, women have more constraints than men. So as adults, they have more than adult men, and also in senior, even if they have less constraints in the external ones, women have always more constraints. The most one have kids, but because, as I said, if they have a constraint, it's because they walk in groups. If I look at the data from the other side, so if I count every person who has the role of the accompanying person, it's 77% of all this work is done by women. Adult women, 15% of men, adult men. There's also a difference, there's the strong facts, as we say, but it's women who carry, so 72% of everything which is physical engagement, in addition to walking, is done by women. Men, only a quarter of all this work is done by them. And if men have an external or individual constraint, then it's because they walk in groups. So half of them are walking in groups, but when they walk in groups, it's like here, they were going to lunch together from work to lunch and back. It was the lunch pause. Because the observations took place during working days at lunch and afternoon, so to have a bit of everybody in and comparable situations. Yeah, what we see of this was women do suffer much, much more if sidewalks are not created in a way that support them or help them in their daily work, their routine, their daily life. And this includes also missing benches or unusable benches, which they have to improve. They have all this bench which we see here. It's not so clearly, but it's of metal. It's a really disgusting place, and it's something, yeah, it's for nothing. Or yeah, they have to find other ways, or you see these small sidewalks and the tree who reduces the sidewalk in a way you can't pass with a buggy with kids or something. So they're much more concerned of it. But usually women, we also know, have much less influence, and they complain less, they have less lobbying, because especially those who are concerned most are those who are not working full day in decider positions. Those who are interested in benches, tomorrow we also speak about benches, which is a very special topic, public seating, and we say it's a service station for pedestrians. So it's the completing part of walking. So what we defined as a term is the multitask walk, because walking is the only individual mode of transport where you have your hands free. And because you have your hands free, you usually do a lot of other things, as we saw, but also activities like smartphone, phone, and a lot of things. But it's always connected. The hands and the feet are connected, as this sculpture, this great sculpture I saw, expresses very well with these lines between hands and feet, and we also have to think of this connection which is there. And when we look on the numbers, so the majority of pedestrians is concerned, cannot just walk, as we had the first picture of this man walking with his suitcase. 45% have a kind of physical constraint or a temporal constraint, because what I have not yet shown, if there's some time, I can show what I did with the physical constraint, temporal constraint, how I measured it. A relative speed I defined, which is also 10%. You see they have stress in their expression of the body and their relation with the environment. And at least 8% do some parallel activities, something I have not shown here. But this is like smartphone, drinking, eating, or something. So more than half of the pedestrians don't just walk, they do something else or have constraints. And all these people who have this kind of tasks, they have, of course, a reduced freedom of walk, but also they reduce the freedom of walk of others. If you have to cross this lady who was with 5 kids around, it impacts also you, even if you may not have any constraint to walk. So in planning, this has to be seen as a whole. There's a lot of interconnections. So what we made then the term augmented pedestrian, that has nothing to do with the augmented reality, but to see the pedestrian in his full picture, because the typical pedestrian, he's neither alone nor free in his movement. He takes all his life with him. There's a difference with the car. In your car, you pose your life somewhere in the bag or on the seat beside you or between the seats. But when you're a pedestrian, you carry everything on you. And it expresses in your time, in your space, in how much space, how many responsibilities you have, the ties you have with the environment, the social ties make you run to get your kids from school or to be sufficiently early at home or in the shopping area. You are really very much influenced of all domains of the city administrations. Whatever decision they make, they influence always the pedestrians. How stressful it is to walk. At what time? Is everybody walking at the same time, the same distance? So this influences the pedestrian on a physical level, on the mental load. Also the need of energy and attention. And we know with elderly people have less energy, less attention. It's getting more space. They don't have space for anything else. And all this together reduces the freedom of walking. So you have less options, less and less options with all these constraints. So whoever designs walkways, but also all the studies you do, one has to think that these are the pedestrians and not the man with the suitcase. And when we speak of walking, very often people speak only of being mobile because they compare the pedestrians with the cars. They treat pedestrians like cars. But the pedestrian is much more than walking. It's not a car. It includes stopping, the very spontaneous way of stopping, leaning, sitting, putting your things down for a moment and not having get them up from the floor, but maybe have something, a bench or something you can stand down. You have the spontaneous interactions you want or you don't want to have. And you have all the responsibility for what you have around you, but also the environment around you. So walking is much more than moving. And I suppose we have 12 minutes. Can I? Okay, then I have 2 slides for how I did the other typology by gait, or allure in français, the relative speed. So as a sociologist, I didn't measure the real speed. I tried to identify 5 categories of how people are walking. It's a speed, but it's in relation to the environment. So the speediest one, of course, is those who runs. But even if you run, you have very different. You have the person who doesn't know how to walk, but you see it's incredibly stressed. He just wants to get to the bus. So in real measurement, he would be slower than somebody who walks very without stress, but he's running in relation to his body. So it's like this one, but can be the jogger, but could also be a person really with a lot of constraints who tries to be fast. You see, it's really, he's torn. He doesn't see any environment. He has only one focus, to be fast somewhere. Then we have the determined walker, who knows also he wants to be there. He's not running, so he's still having both feet same time on the floor, but he's leaned forwards, and he's like, there's a cord which is steering him to a certain objective. He doesn't see anything around him neither. And so these are the 2 ones I described as stressed ones, because they influence. When they run and you see them, they take more space. People give them more space. Then you have the average walk. This is, we have apparently 13% on the fast side and 13% on the slow side, and the rest is usual walker. On the slow side, we have those people who are very concentrated on walking. They are really aware that they are walking, and that's the main occupation for them. And then we have the flaneur, who is strolling around. He forgets that he walks because he's fully connected with his environment. He stops, he turns, and walking is just something going beside. So it's very slow. It's a long time. I could observe them very long on my observational spot. They observed me, I observed them. So it's, yeah. So this is 5 nuances, which can, of course, difficult to make a very, very exact description. And maybe if you would have made the same observations, maybe we would have not fully the same categorization, but in the long, yeah, it's interesting to analyze people like this because it's always parting from their body and not from something relative. And it influences, especially the others, because what I saw then in comparing the numbers, the faster people walk, either from the time or on a certain space, and also the more pedestrians there will be, the fewer persons I saw who were walking there, those who have individual problems, because they avoid them. Somebody who has really problems to walk doesn't go there where people are running, joggers, etc. They avoid the lunchtime anyway because there are the kids on the street, but also the joggers. So it was clear, and with some exceptions, it means the more pedestrians we have is not always a success. We have to be careful. And the faster people walk, they also exclude others who need the safety because they need all attention for walking, and they couldn't manage people passing too fast with them, those who have no time to look at the environment, or they have no time to make a really big way around those who have need attention for walking. So there's also, we have to be careful, more pedestrians is not always better. And so this is the relative speed story. So yeah, if you want to know more, actually there are 2 reports on my ResearchGate. One is in French, it's the one of the pedestrians and benches, the role of benches for the pedestrians. And the other, we did a pilot project, it's more for benches, that is English and German. And for the rest, it's coming soon, so best to follow either LinkedIn or ResearchGate if you want to have the English version of all this together. Thank you very much.
Thank you, Renate. Thank you for the presentation. It was brilliant. And I totally trust the observation as one of the the essence of producing research about pedestrian and urban mobility. I truly liked the presentation. And I'm sure you have some ideas, some thoughts to share. But if you do agree, I would like to have the Q&A session at the end, so we can wrap up all the insightful presentation from all the speakers and continue the discussion with them as a panel, let's say as a roundtable. So now we have the second speaker, Daniel Sauter, who is one of the pillars of the conference. Yesterday I attended a workshop about data measuring walkability organized by him, and I truly appreciate it. The title of the presentation is Technologies to Count Pedestrian, Typologies of Flow Profiles and Extrapolation Factors. Daniel leads the urban mobility research in Zurich, and he has a background in sociology, psychology, and political science, so again, multidisciplinary approach. And he has a 30 years experience producing research about walkability, cyclability, but also public spaces. And he also started as a co-director of the Swiss Pedestrian Association, which was represented at the United Nations, and also one of the people behind the International Charter for Walking. So thank you. So please come on stage. Thank you, Daniel.
Thank you very much, Andrea, for the kind introduction. It's a pleasure to be here. I'll dive right in, starting with the technology that we analyzed in this research. In 9 cities, we tested different equipment. 3 of them were camera systems that we used, video camera, normal video camera, then 3D cameras, and infrared cameras. And they had different analysis options. So some had they didn't store any images. They had the analysis right in the camera. Others we analyzed with software in the after taking the pictures, and some we did particularly for control counts from video directly. We also analyzed a couple of laser scanners and pyroelectric sensors, passive infrared sensors. Most of you might know the echo counter equipment. And we used Bluetooth, Wi-Fi, and last but not least, we also did manual counting, because there are situations where this is still best suited and all the equipment is maybe not the best way to apply things. These are a few situations where we used them in a complex situation. On the top left, in Lucerne, where there's large groups of tourists and they're a problem. We also looked at zebra crossings, how to count them, and on bridges with these 2 different lasers that we used. And what we found was that not just the research question is important, as you would think, but also the survey duration that determined the choice of technology. Mostly because of the energy supply that is important. And the energy supply is also important to find the best installation site. Sometimes you need quite a bit of time to find out where to place your equipment, and that needs to be very well prepared. Also, particularly when you have complex situations like down here, when you have linear movements at the same time as people sort of standing there and lingering around, and like on the right-hand side in a train station, that can be quite challenging. Or if you use video equipment, weather conditions can affect that. Hard shadows, contrasts can be quite challenging. We found that control of the data is very important, because most data had flaws independent of the technology. And then the really, really old question that we're always debating is, how accurate is accurate enough? Is the error systematic? If so, then you can calibrate. If not, you have a bigger problem. We found that the 90 to 95% accuracy rate was absolutely fine. And we found also that the main technologies are there for good, so to speak, and the type of equipment that changes fairly quickly. Now, when you have a short time count of, let's say, 2 to 12 hours, camera systems with batteries and solar are most suitable. Pyroelectric sensors, depending on the place, are also very useful. And when you do a 2-hour count, manual counts are probably best to actually analyze. For example, linear movements on a sidewalk or crossings, whatever you need to know. Now, when you have large-scale route choices, complex junctions, or pedestrian areas, you need usually to count for about 1 to 2 weeks in order to make proper assumption. Camera systems, again, with battery, solar, are most suited. Bluetooth Wi-Fi is also good, but can be quite complex in sorting out the different users. And when you go for longer observation periods, you usually have camera systems that have the energy supply sort of built in. They need permanent power all the time. Camera systems with an internal analysis are then the best solution, or laser scanners. They have also proven to be quite good, or in specific situations, the pure electric sensors can be quite useful as well. So we then ask ourselves, can we actually have a typology of flow profiles? We debated that very controversially over many years, and this was the first trial. And we used a travel data survey from Switzerland, 32 permanent counting points in different cities in Switzerland, and 20 short-term counts that were done. Now, the data is biased mostly towards city center in the German-speaking part of Switzerland, because in the other parts there's just too few or no data at all, like in rural communities, for example. So this is just the first attempt. And we found that when we look at these counters, or take the data from these counters and the travel survey, there's 6 main types that we distinguished according to activity, the main purpose of the trip, or according to location, depending on which was more meaningful or was more in the forefront. So these are the 6 types here that you can see that we could distinguish. Type 1 was the local recreation, leisure, in a park, for example, very clearly, a very clear pattern. The shopping axis downtown, usually in old cities, also very clearly distinguishable. Commuting, of course, for school or to work. Then the type 4, the local or neighborhood centers. They usually are connected to a public transport hub. And distinguished from that is a neighborhood axis. That's not a small neighborhood street, but a street in the neighborhood that has usually a bus line or tram line on it and several shops on it. And as a special case, we found in 2 or 3 cases, access to nightlife areas. They have a sort of special pattern that we just see in the next few slide and few graphics here. Again, if we start with type 1, with the local recreation, you see there a dent at noon. That's usually joggers in most cases that go to the park and jog, but relatively and in absolute terms, the highest volumes are on the weekend, Saturday, Sunday. Shopping axis, highest peak on the Saturday afternoon, fairly plausible. During the week, it's evened out. Work or commuting, interesting enough, the 3 peaks that show up more or less everywhere. But interesting is that school is higher, the peak is higher in the morning, and work higher in the evening. The high peak at noon is due that in Switzerland, most kids still go home at lunchtime. So that's the peak, explains the peak there at noon. Now, if we go on to the local neighborhood centers with the public transport hub, you see the peak in the evening, not much peak in the morning, in differentiation to the neighborhood axis, where there is also a peak in the morning. And on Saturdays, you have quite an evened out volume over the whole day. And then the access to nightlife, you can see that on the Saturday morning, so late Friday night, you have quite a high volume. And then on Saturday evening, it doesn't go down as during the week. So having had that, we asked ourselves, can we actually extrapolate the data from these short-term counts to a full day? And when you look at the result, you see that overall, about the time between 5 and 6 is the best for most purposes or most types that we've analyzed, maybe the hour before, the hour after as well, except for the education, where the best hour is in the morning, between 7 and 8, and between 12 and 1, again, due to the special situation in Switzerland. I imagine in the long term, this will disappear at noon. So all in all, it's a fairly clear situation when the best hours are to count. And if you actually have to do the counting, then you go, for example, out in a local neighborhood center with a public transport hub, type 4, between 4 and 6. You have a result after these 2 hours of clicking or observing, and you multiply that by 5.4, you get the result for the day with a relative error of about 11%. Now, if you do that on a Tuesday, which is the best weekday to count in such a location, you multiply that by 0.9, and you get the average for the whole week, including Saturdays and Sundays. And if you just want the workday, Monday to Friday, it's basically the Thursday result, 0.99, and you know it has a relative error of around 8%. Now, just very quickly, double hours are better than just single hours, which is sort of understood. We confirmed Tuesday to Thursday is the best days to count. Spring and autumn are higher than the summer and January, February, with some exceptions. And that's important. Peak hours depend on the location. So midday peaks are often in the city center. That's to be considered. And Sunday for leisure, local recreation. And also important is the directional load may vary throughout the day. So in the morning, you might have all people walking this direction, and in the evening, this. So if you count in the morning or in the evening, that depends then on the load that you actually get or the direction you get. Now, the last point I want to make is an international comparison. Is it possible? Is it meaningful? Hopefully that will also be some food for discussion. Thanks to Paulo Gambra from Lisbon, we did a comparison of 3 types, actually several, but these 3 types looked very interesting, like commuting, shopping, and going out for lunch, meeting. And you see the patterns are fairly similar. In Lisbon, they counted manually in several streets and came up with these types. In Switzerland, it's again this automatic equipment. You have again the exceptions that in Switzerland, the midday peak in commuting is higher than in Lisbon. Here we don't have as much activity for shopping during the morning hours, and we didn't find any streets where we had a sort of exclusive lunch or meeting time usage, but we had the travel survey data that showed us you can also detect that in a travel survey. So the conclusions and challenges: travel survey data, if you have pure purposes, differs from street counts. And of course, that's due because there is a variety and a mixture of different purposes on the street. There's hardly any streets with just a single purpose, of course. But interesting enough, every street is different in terms of volume or distribution, but often you can find and put it into some kind of type, which I find still an interesting phenomena. And the results, of course, depend if they're in the inner city or in the outskirts, so that has to be considered as well. And then we found, interestingly enough, some differences in the structures and cultural practices. For example, we didn't find a street in our sample of counting sites where walking the dog it was actually sort of an exclusive almost activity. But I was fascinated by Renate's presentation where you had the category of walking the dog as well. So yeah, that's interesting. We didn't have a street where that was sort of a determinant anyways. Of course, we need more data in general, but it would be nice to also include sojourning and play somehow in this typology. And eventually, our goal should be, or could be, to define a spatio-temporal walking pattern scheme where we combine, for example, that data with the structural analysis, and we could make models. So the idea would be to count in many streets of a neighborhood or of a city, and then, like for 2 hours, extrapolate that data and have a fairly good estimate of the actual street counts, and then could inform models in the future that actually will counteract the pure car-oriented models that are in place right now. And of course, finally, I'd be very interested if you have done anything like that, if we could compare more different settings and what the pros and cons are. So I thank you very much.
Thank you. Thank you, Daniel. And impressive, really. I would have myself some questions for you, but we can wait for the Q&A session. And I just want to comment how much this kind of data are useful if you have a theory in mind, and also the knowledge of the context you are going to observe. And it was pretty clear you can manage both. I mean, having good, robust data, but also a walkability theory in your mind to structure your data. And it was excellent. So now we have the third speaker from remote, from Chile. Her name is her name is Isabel Escobar. Probably she's online. So I can introduce her, and then she will present from remote. Her presentation is titled Our Right to a Walkable City. And Isabel works as a professor and researcher at the Faculty of Architecture of the Universidad de Especialidades Espírito Santo in Chile, and as an advisor of the Transit and Mobility Agency in Ecuador. She works developing projects of tactical urbanism, public space, walkability, and active mobility for various municipalities and universities. So it's really a pleasure to have her. Yeah, Isabel, sorry, can you share your video, your monitor? Difficult. If not, we can jump up the fourth and then come back to Isabel if she has some. We jump up? Okay. So David, sorry. So we kindly introduce David, which is who is the fourth speaker, David Powell. The presentation is titled Automated Extraction of Pedestrian Activity Using Graph Database. So another approach for collecting quantitative data. And David is lecturer of engineering at the School of Electrical and Electronic Engineering at TUD. He has 10 years experience in teaching and learning at the University of Dublin, Technical University, and his research approach is based on focus on the IoT application, so Internet of Things, and the possibility to apply these devices connected together innovative data. Thank you.
Hi, welcome everybody. My name is David Powell, and I'm with the Towards People-Oriented Technologies Research Group. And I'm going to be talking today about how we're actually processing some of the information from a walking study. If you want to know more about the actual walking study, if you talk to Alam Alamburi from our research group, she's around this week and she's here today actually, and she's doing a poster on Thursday, and she'll be able to fill you in a lot more detail on the actual walking study. And also Mayank is around as well, who's very good on Bluetooth, And this is some of the underlying technologies. I was also involved in the hardware for collecting it. But what actually got me interested was the actual data we collected and how we were going to process it. And also processing it in a way that we can gain extra knowledge from it and extract information. So I think I'm one of the only engineers talking here today, but I'm going to talk about graph databases from a practical point of view. And I have a GitHub here. So if anyone's interested in having some of the data and actually replicating what I'm doing here, you can go to the GitHub dpal.to/walk21. But what we are interested in is actually explaining about graphs and graph databases and how it differs from the traditional approaches of using like SQL database or something like that. So the objectives of this work are to learn a lot more about the graph data model. It isn't something that's totally new, but it is something that has been used by companies like LinkedIn, you know, Facebook, things like that to connect related things or people, etc. We want to learn about how to store our information and query it in graph format, the advantages to doing that. Can we compare things like journeys if they're in graph format? A lot easier than a traditional database. So what we're going to use is Neo4j. So I should say is the top set of objectives here are general objectives. We have some specific ones for the walking study down below. But one of the main ones that was really interesting to me was not to write lots of complex code. Because when I speak to the research group, we're multidisciplinary. And early on when I was talking about this, I go, oh, well, we could write a program to do this, or we could write a program to do that. With this, I didn't want to write lots of code, right? I wanted the researchers to be able to actually exploit it, given the right tools, etc. Okay, so that was one of the main objectives. There are 2 Python scripts used as part of this, but hopefully it's minimal, and most of the work has been done by the actual graph database. In terms of the walking studies, we wanted to see how databases can give us the graph database gives better understanding of the topology, so where our collection nodes are located to collect the data, and also how we can understand the actual journeys that people make and how we can compare journeys between each other for likeness, etc. And can we validate journeys between, you know, is this journey valid based on our collection topology, or are there errors in the data, etc. Okay, so what are the previous approaches people would have done in the past? Well, most people have probably heard of a CSV file. Some people may not have. So CSV files are comma-separated variable files, and they're around a long, long time. And if you start to do a bit of research and someone says, we have some data, quite often they'll email you maybe a CSV file. And you can open that in Excel. It's not particularly well-structured data, though. It's text. And you may have to interpret the first column as a number, the next column is, you know, a location or something like that. So we have to quickly move away from CSV files, although they're generally used for our input. We generally moved to some sort of database. Now, relational databases aren't anything new. They're around since the 1960s. Most people maybe done a course at undergraduate where they had a relational database, maybe an SQL database. But these databases are based on a schema or a rigid structure, right? So you design your tables. They're generally optimized to reduce the amount of storage, because storage was very expensive in 1970s, 1980s computing. Storage is now very cheap. What's the problem in our data centers is the cost of computing. So SQL databases are optimized generally to minimize the storage and not having replicated data, etc. But actually for our type of data, querying them is actually quite expensive. There's a large overhead. So we want to be able to very quickly compare journeys between each other, etc. So when I first started to look at the graph data model, one of the first things I've done was look at our collection network. So I know you're up on the campus today, our new campus. So this is a subset of the collection network with a triangulation on top of it. And I thought this is a good example of a graph. So the round nodes represent the actual collection nodes, and the lines between them are what we call the relations in a graph database. So when I started seeing this, I started saying, okay, maybe this has some merit. So this is what we call the topology. And this is how one way we can store information. It doesn't necessarily have to be over such a wide area. I was saying to someone earlier, this could be within a building, you know, it could be within a, you know, on a much smaller scale. But this is part of the walking study, was to analyze over a much larger area. So what is a graph, and, you know, how does this approach work? Well, the graph is constructed of n nodes and relations. They each have a type, and that can be used to filter the graph. We'll see that in a few minutes. And both the nodes and relations can store information. There's also they store connected information. There's very efficient algorithms that are built into these graph databases to allow you, for example, to calculate paths through the graph, to compare graphs for similarity. The main thing is they're highly optimized and they don't require this rigid schema that you have in an SQL database. So as researchers, I meant to say this when we're talking about SQL databases, SQL databases are brilliant when you know the problem you're trying to solve, right? You know you're trying to do an ordering system, you need to track orders, customers, so stuff like that. SQL databases are brilliant for that. But as researchers, we don't actually know the questions we really want to ask, right? So the likes of a graph database, once we have a basic data model, means we can bring the data in and then we can decide on the scenarios or the questions that we want to test later, okay? So it's not as rigid. It doesn't need this idea of a schema. So what technologies are we going to use? We're going to use Neo4j, which is about 15 years old in terms of database technologies, but really it's only in the last 5 to 6 years that it's been used outside of companies like LinkedIn and stuff like that to actually natively store connected information, okay? Supports a variety of built-in data types, including GPS coordinates. So as soon as I saw this, I said, okay, this is good for us. We need to be able to record locations and events. That's going to be good. Supports querying of this to gain insights to the underlying data. I don't like going to presentations, though, where people actually install lots of fancy software that I can't use myself. So in terms of what I'm going to show here today, I've done this on the free cloud version of Neo4j, so you can literally sign up for a free account, and you can do this in a web browser. So you don't actually have to install any software in your desktop, laptop, anything like that. So basically, everything I've done today was done for Neo4j in Firefox or Google Chrome. You can actually, everything from loading the data in to actually querying it can all be done in a web browser, right? So this got me interested as well because all of us have our laptops full of software. We can't get licenses for very specific software sometimes, depending on what we can install, etc. So being able to do it in a web browser allowed me to work pretty quickly on this as well. The first problem was loading the data. I had my CSV files that I got from the researchers of the locations, but because this is cloud-based, you can't just load it from a file. So one of the solutions was just to take it from the likes of Dropbox or Google Drive. So this is the basic approach I had for bringing in topology. I started with a GPS locations. This is basically the locations of our collection network. If you wanted to do this yourself, you could put in your own locations, or if you don't have locations or something you're trying to study, you just want to use our data, I have this file hosted on the GitHub. Okay, so I was able to bring that into Neo4j. I was then able to work out the triangulations or the relations between them. So I did use a small bit of Python to do this and do this step. The next step, the purple step there, is going to openstreetmap.org and bringing in the walking directions and the walking distances, okay? Because it's a walking study, I wanted to not just deal with the actual locations, I wanted to query openstreetmap.org and see how long it took to go between them locations, okay? We could also bring in accessibility information, etc., and we'll have a look at that in a second. And then the last thing I wanted to do was export the routes. So this is the relations between the nodes. So the first step, the red step, got the M nodes, and the next 3 steps got the relations, this connects relation that joins the nodes together, okay? I then had to validate the topology to make sure everything was looking good in terms of the actual integrity and stuff like that. So when I click on a relation in the browser, it shows me a number of attributes for that relation. So the attributes you have is the distance and time. That's the linear distance, the Harris-Sine rule, to work out how far things are apart. And I also have the walking distance and the walking time brought in from OpenStreetMap. So now I can actually check linear distance, 256 meters, walking distance, 371 meters. Yeah, that sounds about right. These were inside our campus. And a lot of the data, all that data came from openstreetmap.org, and it actually seems quite good. I also asked Neo4j the distance between the nodes, and it was out by 28 centimeters. So there's probably some rounding in one of my calculations. But again, it further backed up that the topology model is actually good. If you are interested in using our data on the GitHub, you'll see there's a load locations and a load relations script. If you run both of them on your database, it'll actually bring in a network, something like this. Okay, so this is a subset of our overall collection network. The actual physical location doesn't really make a difference, but what these are is on the nodes, it's showing you the actual locations. These actually mean something to the researchers, and then the relations join them together. So we now have something that we can query. So one of the simplest scenarios was, are there any routes within here between the points that aren't optimal? So I came up with a scenario and said, well, maybe if it's 2 to 3 times longer to the walking distance above the actual linear distance, maybe that's considered a non-optimal route. So actually the query for that is here. So this is how we query in Neo4j. It's called a match, and they use a little bit of ASCII art there. The round brackets describe it as a node, and the square brackets describe it as a relation. So this is basically looking for any location nodes with a connect relation. And I'm interested in only the ones where the walking distance is more than 2.5 times the linear distance between them. So I'm looking for basically routes, maybe where there isn't a gate or a direct path, maybe there's a building in a way. And when I run that query, I get a number of the routes are potentially non-optimal, and I could go off and look at them. If I reduce that down to 2 times, I get more and more of these routes obviously come in. Okay, so once I saw this with the topology, I said, okay, this is actually something useful here. And I haven't had to write lots of code to do it, because the query, I've only a very small set of attributes here in each of my relations with nodes, but actually the query isn't too bad for anyone who's going to start looking at this. The next problem was the actual journeys, because the topology is really like metadata about the study. And although that's useful, the real thing I wanted to do was start looking at journeys. And I didn't want to look at a huge amount of journeys at the beginning, because I wanted to do something relatively straightforward. So I asked Alam to give me just a subset of typical journeys through the network. So I've done a slightly different approach for bringing these in. So this is another CSV file with some journey information. This has all been anonymized as part of the survey, so we don't know who the person is, etc. But basically, we have the locations, we have some timestamps, and we have a journey ID. And I wrote one other little Python program for this to basically take the CSV file and generate what's called a cipher query. And again, this can be brought into the browser and just pasted in. And what it does is each line of the CSV becomes an event, and it joins all them events together into what we'd consider a journey, and basically generates a graph of that journey. Okay, so create journeys from CSV, again, that's on the GitHub. And what it does is it gives us a nice graph representation of the journey. Now, this is only one journey. There was about 10 others that brought into it. And as you see, it has a start relation and an end relation. And we can now query this journey. We can also very quickly, using the built-in tools in Neo4j, to compare if this journey is like another journey. Do they have the same start and end points? So you could ask it, give me another journey that has a Keir 14, which is Kirwan Street, I believe, on the far side of campus, and FP12, which is another location. Okay? And the actual job of separating out the journey is actually quite difficult, and Alam can talk a lot more about that than I can. But this is a really, really good way to represent the journey. You can actually see here, they go to CT office, they go to another node, and then they go back to CT office 6, and then back around. So this could be an anomaly in the Bluetooth data. We're not sure, okay? What we could do is we could query it against the topology and see, does that next relation, the time for that, does that match what the topology says it should be from OpenStreetMap? It could be that they're selling coffee at node or a C7. We're not sure. It could be that just the Bluetooth signal was received there. But that's a problem with Bluetooth, that it travels in open space. Okay? We're just coming up on 12 minutes, sorry. A couple of minutes more. Okay, grand. So we can now start to compare journeys between each other and compare them to the topology, which is really interesting. Another thing that strikes us is, although this is being pre-processed and we've got just a single event node for each interaction here, Bluetooth, and when we're collecting data, is probably more like zones. So we could have another incarnation of this where we have a zone with entry relations to enter the zone and exit relations to leave the zone. And I'm still evolving this approach to represent the journeys. that will tell you a lot more about what happens, how long they spent within a particular zone. Could you be a member of more than one zone, etc. So that's something that we're currently working on with our graph approach. But it also allows you to drill down and query the journeys. This is basically where I've done another match query for a particular journey, and this is where I'm subtracting the time from the first node to the last node, and it's going to give me how long that journey actually took through the network without actually having to go through every individual node in the network. So there's loads of different ways that we can actually query this information now and extract information from it very, very efficiently. Okay. They want to save any questions till the end, but that's my little bit about graph databases. Thanks very much.
Thank you, David. And it's really interesting, by the way. I really appreciate the application of graph theory, and also I think, it would be needed 1 hour to have a better understanding of I think your research is going also to produce some, let's say, results about the semantic, let's say, not only the space syntax, but also the semantic, the hierarchy in between the spaces and the places in the environment. So very good. And Isabel, are you online?
Yeah. Yes. Hi. Can you hear me?
Let me introduce you again very briefly, and then I give you the floor. So, Isabel Escobar, the title of the presentation is How I Write to a Walkable City. And Isabel worked as a professor and researcher at the Faculty of Architecture in Chile. And also she worked as advisor of the Transit and Mobility Agency, ATM, in Ecuador. And she worked developing projects for tactical urbanism, public space, walkability, active mobility for various municipalities and universities.
Thank you very much. Okay. Thank you very much. I only want to say a correction. I work as a professor in US University in Ecuador and not in Chile. But thanks. Okay, everybody's watching the presentation?
Can you hear me? You have to share your screen.
Okay. A minute. Share screen. Okay, can you see the presentation right now?
Perfect.
Okay, thank you very much. My name is Isabel Escobar, and this presentation is made by me and Ricardo Pozo. I'm an architect, and I work at the US University. I started to work in this topic around 10 years ago when I did my master's degree in Germany, and I attended a couple of Walk21, and I really like it. It changed my point of view in this topic. The topic for today is a ride to a walkable city, assessing walkability and accessibility to the public space in Guayaquil. So I would like to start with this quote from Jane Jacobs, the streets and their sidewalks, the main public space of a city, are its most vital organs. What is the first thing that comes to mind when thinking of a city? It's streets. When the streets of a city offer interest, the whole city offers interest. When they present a sad appearance, the whole city looks sad. So I really like this quote because we are going to show you some really nice examples of streets and how can people change the state of mind and transform public space into a livable spaces. Okay, thinking about walkable cities in Guayaquil is a little bit complicated, difficult, and maybe impossible for many people because Guayaquil is a big city that grew with a bad quality of urban planning, and that's why we have a bigger population that depend of the car use, and also many of the travels that people do are made by car. That's why I would like to talk about this street. This is Panama Street in the city center of Guayaquil, and it is recognized for its colonial urban layout and its proximity to some historic squares. During the second cocoa boom, Panama Street was an example of the appropriation of public space through the whole city, because as you can see in the pictures, the street were used as a space for dry cow seeds. So, yeah, for us, assessing walkability in Guayaquil is really a challenge, and this presentation will show you this project because we as a team started to work in more walkable space in the city, and during 2019 the municipality started to think in the importance to transform space for walkable users. This is the case of the streets, and that's why we as a team from made of Ricardo Pozo, Florencio Comte, Juan Carlos Bamba, and me started to plan this master plan of Calle Panama, and our main focus was transform the streets and do it more walkable. As you can see here, we did a master plan with some of the main ideas for that study. We also tried to took some nice examples from abroad. For example, this is a very good example from Vienna, the before and after. So we needed to convince people that the idea to make a safe and pedestrian street is available, and that's why we took examples from different cities. For example, this is in Mexico, this is in Argentina, and of course, we wanted to show the people that there are a lot of benefits in doing many space for pedestrians. Okay, in Calle Panama, at the beginning, I would like to say that nobody wanted to do it because having a pedestrian space would cause a lot of traffic, especially in the downtown. So that's why it was difficult at the beginning. But the idea that we had to convince people is first collecting main data. That's why we started to collect data of the streets with some tools. In this case, we used the tools from Jan Giel, and we started to count people in the streets. But normally what the mobility agency does is counting cars. That's why it was very interesting for the whole city to see that we were counting what people really do in the space. For example, people walking, people standing, people sitting on benches, or data related age or gender. And we got a lot of great results. At the end, we showed that the people on the streets were doing social interactions, and it was very important for the city. And here you can see some of the before and afters of the project. I took this picture in October in 2019 when I was doing the walk index tool in the Calle Panama Street. And as you can see here, the before, it was a parking lot. And nowadays it's a space, plenty of open space for pedestrians, for dogs, for restaurants, for people walking, and so on. Here we have another picture regarding the street, Panama Street and Zárraga. And the idea here was that the municipality took the study and they started to build some of the plazas, some of the pedestrian streets. And here is the before and the after. As you can see here, you can see also many restaurants that are now nowadays in the streets. And it's really interesting how you can go there with children, with dogs, with people with disabilities, and everybody is happy. And here you can see other block of the street, the before and after. And here at the same spot, but with many people walking. I would like to say that this picture is a pilot project because the whole street is not all space for pedestrian right now, but we did a pilot project in order to prove to the city and to prove to people that it's possible to make some changes in the streets. And also, I took some pictures at night in 2019 and look how the place is right now at this more or less the same hour, with bikers, with people eating, and also with some green areas. This is another picture of the Panama Street at night, the same spot. And nowadays we have some benches for people and also for some spaces for people that would like to make music. So this is the master plan. As you can see here, we try to implement the whole project in 6 blocks, but at the beginning it started only in these 2 small streets. But the idea is that nowadays the municipality is doing some of the projects that we propose, and the idea is doing more walkable at the end. So as you can see here, we wanted to show that even though there is an open street, it's not necessary to have bodyguards everywhere to make it secure, because it's the people who make the place secure. Here in Guayaquil, we have a lot of problem with insecurity. That's why it was a little bit complicated for people to understand that the open space, the street, is an open space that it could be used for another thing and not only for cars. And this is the pilot project that we implement in September 2021. And as you can see here, you can see children using scooters, people with dogs, and also the good point here was that it was implemented by the Urban and Transit Mobility Agency. So as a part of a main idea of the city, in order to convince people that this is a great project in order to have a healthy city. And here you can see some pictures regarding other space in the city. Local vendors or people with business have also many advantages here in the project. They started to put other local projects like this lady here with the bikes for children. They rent the bikes for only $1, so it has also an economic benefit for the whole community. And also you can see here to the right, people painting in an open space. And in the past, it was very difficult to find this kind of image in Guayaquil. At the same street, in other blocks, it was important for us also to show that for women, this is a very safe space in which you can go with your children and drink a coffee and have a nice day. And also we wanted to show the people that it's possible also to combine business and public space. That's why you can see pictures with many local vendors. This was the pilot project in 2021, and we got very good results. And we did more or less the same, the collecting data analysis in other street, this is 9 Octubre Street. We test the jungle tools with many of my students, and it was really interesting because at the beginning, the same thinking was that it was impossible for people to walk along this street because it's the main street in Guayaquil, in the city center. It's the main corridor. But as you can see here, the street in the pilot project was full of people, full of children, full of families, and it was really interesting for us to get these results. And yeah, all the data that we collect was not only quantitative, as you can see, also qualitative. And I think this was the main point of view that we wanted to say to the people, that it's not only important to count cars, that it's important also to count people and to know what the people is doing in the space. So here we have some of the results that we got from the counting data. And this is my last slide. I just wanted to say that for us, it's the Walk21 network is an extremely powerful source of data, and we really want to say thank you to Walk21 to accept our presentation, the case study of Guayaquil, because we wanted to show you that in developing countries, it's also important to make the streets available for people and to make more walkable cities. Thank you very much.
Thank you. Thank you, Isabel. I think now the Q&A session could start. We have around 15 minutes to continue the conversation. Most probably, Isabel, you cannot join from remote to the Q&A, so because of, there is an echo with the mic. So I would start if someone from the room has a question from taking into account the insights from your presentation. Fine. So if you have any question, I think we can continue the conversation with Isabel or. Okay. So Isabel, thank you for the presentation, and it was really good. And I want to invite all the speakers to the floor, on the floor. So David, Daniel, and Renate, would you mind to? Thank you, man. I think it was really, the session was really dense, let's say. It had many information, very useful for researchers, but also for decision makers. Yesterday during the workshop, we discussed a lot which kind of data we need, which is the most important data set you want to share to a decision maker. I think we need somehow to prioritize the data we collect, but also to select the one we want to present to decision maker, policy maker, which is the first layer we want to start from. So do you have any question, please?
Daniel, I got a few questions for you. First technical one, when you said you're counting pedestrians for 2 hours, do you count for 2 hours straight, or you count for 15 minutes in 1 hour and then 15 minutes in another hour? And the other one is that regarding pedestrian counts, is the question how big is the variance from day to day or from week to week? I also do pedestrian counts. And I tried 12 points in a city, 3 weeks at the same time, on the same day, 3 weeks in a row, and I had difference between 15% to 30%. So the question is, how do we get this error down, or how, if we can at all, because these experiments are expensive, very, very few, and I'd say the global database is non-existent yet.
Thanks, Jav, for the questions. With the first one, usually 2 hours we do all at once. So like from 4 to 6, because then you can extrapolate. But if I do it over the whole day, I might indeed do 15 hours per hour and the moving 15 hours. So it's not every time from 30 to 45, but it moves. And I have to watch some depending on the space. And that also ties in with your second question of where I count. Like, am I in the school area? So there's this effect of the school. Am I close to a public transport stop? Well, that affects automatically a quarter-hour count or a count in a certain time frame. And then I look for the weather. It should be usually not raining. On average, the weather doesn't have a huge effect, except for snow and really cold weather on leisure and shopping. That's what we found in general. But if you want to extrapolate, don't do it on a pouring 2 hours. Of course, I mean, you know that. But that's a clear thing, that if you take an average day, not in the school holidays, not during 40 degrees Celsius, you should be getting a fairly stable result. What you describe is a fairly large margin of error, but in general, I would assume the margin of error is between 5 and 10%, and that's for me in the acceptable range, because we'll always have influences by chance. And if you want to increase that reliability and validity, then you have to count several times and take the average of that. But you know all that yourself. So, but would you agree with that?
What I'm missing is that we don't have like a comparison. Like what you said, the next step is to have some international comparison of numbers, even of how many people are needed to support the commercial street, for example. We don't have that yet.
Yes, I agree.
There's another one.
Hello? I don't know if that's any better. Can you hear me now? Yeah?
Yep.
Just on that point about like sharing information. Oh, sorry. Just on that point of sharing information, I'm Damon. I work with Dave and Alan and Mayank. And I'm interested in that idea of like allowing information about pedestrian activity to be shared among the community. And I'm wondering, are there any projects or work to have a database, they have an activity monitoring indoors, or are there formats indeed to allow that sort of information to be exchanged between researchers in the community? Does anyone know of that type of information? Like whether there's a format or a database that can be used to share a database of walking activity?
Well, in Zurich, if I may answer, in Zurich, the counting data is all open. So you can call it up and import it, any of the counting sites. But you do need to know a little bit where they are, what the tricks and treats are there. It's not all that clear. I find it super that it's open data, but take it with a grain of salt. There might be, like we had one spot, if I just may quickly add that, where I found there was always a strange appearance. And I found out that every second week, there was between midnight and 11 o'clock in the morning, there was data missing. There was usually around 0, maybe a few that usually had a count of every hour of several hundred. And I found out that's the day when they collect cardboard. So the store owners put it in front of the counting equipment, and then, every second week. So my Thursdays had always a dent in the morning, and I just couldn't figure out what it was till I once walked past there and I saw it, what happened. So then it was bingo, and that's the difficulty when you have this data open source and people don't know what's actually happening. I'm not sure if I answered your question properly,
but I guess, I mean, what I understand from it is that metadata, shared metadata would not be enough. Like if you've got the same design for how you store your data, you still need extra information as well to be sure to understand it.
Yeah.
Okay.
That's the caveat, yeah.
If I may add one point, you mentioned during your you mentioned during the presentation that the sensor you used are GDPR compliant because by definition the quality of the image is like controlled as low. But I think the elephant in the room is the GDPR. So if you collect data with a high definition format of the image you cannot share, you should be destroyed after 2 days, 5 days. But I do agree we are missing an open database. And I recently went through a good one, which is managed by Jülich Research Center in Germany. They are very much focused on experiments about pedestrians, so control situation in laboratory setting, but few videos with also trajectories already annotated about public spaces in New York City, as an example. So if you are also looking for AI machine learning application to automatically count pedestrians, you need also annotated video, not just images to train your algorithm. And Jülich, it's a few good one, but I mean, could be the results of the conference also to talk to Jim and say, why don't we start somehow to share the information we have, the data?
Just comes to my mind, there's also a German website, I think it's called High Street, hystreet.com, and that data is counting in shopping areas all over Germany with laser counters, and that data is open as well. They share that on their website. So I'm sure there's more. I just don't have the overview, and it's a good suggestion that we sort of start maybe collecting where there is and that gather that information and compare it with local knowledge.
Hi, I've got a question for Daniel again, if that's okay. Oh, two questions, actually. One is, how did the technology differentiate with and deal with cyclists? And then secondly, if you wanted to count cyclists, which of those technologies would you recommend? Is there any one that's better?
Yeah, different ones. The laser, in like one of the lasers we use, they can differentiate cyclists and walkers fairly precisely, so that is no problem. There's a problem when there are cars in, but usually you have to have a setting where there's none. Also some sort of pilot technology like this infrared camera that's developed by that's the university, not the EPFL of Lausanne. That is very interesting too. They can distinguish all modes and are privacy safe. And others, if you count, like the echo counter system, can also distinguish between cycles and pedestrians, depending on where you are. So there is technologies, and some of the software can actually figure it out. In terms of software, we found really huge differences. Like there's free software, like Data from Sky, for example, which is really very useful, but not precise at all, but hopefully they can develop it. I think there's developing that in the Czech Republic. Very interesting tool, but unfortunately at the moment not usable. And then we used the other one, MioVision, and that was amazingly precise. We only had really large crowds of pedestrians and stark shadows at light shadow contrast at lunchtime, combined with large crowds where they were having some mistakes. But even at night, even with rain, we checked all that, they were fairly reliable. So it really depends a lot on the software, and they can actually distinguish cyclists from pedestrians as well. We didn't count the cyclists, so we just noticed that they can do that, but you need to commission that separately, and it costs extra. So yeah, there's always advantages and disadvantages and limits. Does that answer your question in a bit?
Is there any other
maybe
question?
at EPFL in our ETH Lausanne, we have Professor Alahi. He does computer vision, and it seems to be a very strong way of counting, and it's immediately anonymized, so you have no problem with the data projection.
Yeah.
Alahi, Alahi. So if you look, he got a lot of prizes for this.
But if I can add a short comment, let's say, out of the technicalities, let's say, which I really like a lot, but I mean, the point for me is like, if you do collect data within the GDPR umbrella, so let's say, is protecting your research, you see what I mean? But also if you need to provide information about the research to the end user, and somehow is a more virtuous cycle for the project. So we did, let's say, a test bed in Bologna, and it was necessary to apply for the GDPR, let's say, procedure, doing some paperwork. It required 1 month and a half. But at the end, let's say, the neighborhood, the inhabitant of the neighborhood were very much aware of the scope of the research. And I mean, also to avoid the big brother, let's say, bubble when using camera sensors to count and profile. And by the way, I found really interesting that right now we could have some technology enabling us to do the same research of young girl, let's say, counting, profiling, trying to understand the actual usage of space. But also the next step I see is to use camera to profile pedestrian by age, by gender, but not using, let's say, their speed or trajectories, but now it's technical, but let's say to adapt the bounding box of the algorithm to recognize the differences in the profile of pedestrian, to have a, let's say, more informative picture of the environment we are observing, let's say.
Can I add in here? What I'd be interested in is exactly that, adding the qualitative aspects of, like we have the typology according to location and purpose. Now it'd be interesting to have a typology that ties in with what you're doing with the type of person that's there. So is it used mostly by elderly, like with walking the dog, or is it used by people with children, or mostly women or men, or who is there? So tie in that qualitative data, and that's what you suggest. If we can get that from the images somehow, like our infrared sensors don't recognize if it's a man or a woman or how old it is, that person. But would you see some potential in that? Like, could this person you mentioned, I unfortunately don't know him, which is a shame. Could that be a tie-in somehow? Would you see anything like that?
It's our plan to integrate it. Yeah.
Okay, excellent. Because I think that would be the next step.
Yeah. We have now some indexes, and the good thing about it is we see with these indexes we developed who is missing.
Yeah.
It is otherwise very difficult. If you count only noses or heads, you don't know who is missing.
Exactly.
And this allows us, so I have now a lot of data for different types of crossings, and so we see who is missing, and we try to find explanations for it. And this helps to identify, is it a problem or is it not a problem? So yeah, we see where are the dog walkers. There are 7% dog walkers. There are 0 dog walkers. So this is important information. Where do they choose to go? The dog walkers are important for security reasons. They're important for to see that because they have the choice usually, where it's nice to walk and where not, what to avoid.
And so far we could do that. Like we did manual exactly counts like that, and we found that in parks there were no elderly, and the reason was because there were large steps, so they couldn't access it. But could we also do that with automatic equipment eventually?
That's my idea, because doing the work I did is very work intensive, but it was good for developing the typologies and having some indexes. But doing it on a large scale, you need to automatize it. So I'd have all the subcategories, the descriptions, a lot of training that it sees the same things as I see.
Yeah.
But it's the direction we want to go. Yeah.
And if I can add, I see very well also the research from you, David. I mean, the way you look at the environment, I think, is like camera and manual counting look at pedestrian from a very operational point of view. Let's say how they do behave, but you look at also the way they plan from a tactical point of view, their daily routine. So I think it could be, this counting activity could be totally in line to validate also the...
Understanding the topology and where things are located.
Could you tie in these different nodes somehow with the different counting points? Like, would that be, I haven't thought enough, that's all new what you're doing to me, but very interesting, and I am going to think about it, but just spontaneously, is there any way of connecting these sort of counting sites with, or could these counting sites be placed strategically to tie in with your nodes somehow?
Yeah, you could definitely. You could obviously represent the frequency information on the graph. I guess you're asking is, could you use it to influence where you actually place a counter? Is that,
for example?
Yeah. Well, if you look at the data comes from OpenStreetMap, actually will tell you the preferred walking routes. So it could be a big park or our campus out here. It actually tells me exactly the paths through the campus that people would generally prefer to travel on because it's a nice path. So you could, with the OpenStreetMap.org data, you could actually use that maybe in planning your study. Yeah, absolutely. Yeah. I automatically gathered in that information into the graph in the background, but yeah, definitely it could help you with placement of nodes and detectors, etc., for counting. Yeah.
And like with Wi-Fi, that's sort of what you do anyways. We had also one particular train station we analyzed with Wi-Fi for the routing choices and how many people actually just cross, or they cross underneath to go from one part of town to the other, and how many people are actually going onto the tracks. But it'd be interesting to tie in that kind of Wi-Fi information.
Yeah. Yes, definitely. Like we although we did it with Bluetooth, we know within buildings where you have large-scale Wi-Fi deployments, we can use the graph technology and the journey information very easily tied in with Wi-Fi.
Yeah. Like yesterday, there must have been a parallel workshop using Bluetooth. Were you?
Well, Mayank and Alam were involved in the Bluetooth workshop yesterday, talking about the technology behind that study. Yeah.
Okay. Yeah, that'd be interesting. Missed that, of course.
Yeah. Well, Alam will have our poster later in the week. I think it's Thursday.
Oh, excellent.
So you can come on to that maybe.
Excellent. Sorry, we monopolize here the conversation.
I think we have to, unfortunately, we have to close probably. Yeah, there is one question. Yeah, go ahead, please.
No, I was wondering if you had any interesting examples of how your data has instigated change within community projects or within cities and city design and planning. Oh, sorry. Did I go too fast? Sorry. Basically, do you have any examples of how your data has changed city designing, city planning, or community projects in general? Or has it been used that way yet?
Are you asking me or?
It's an open question. Sorry, it's an open question in general, yeah.
Why don't you go ahead?
My projects are quite new. So we didn't make research on the impact because the reports just came out. So that I don't know. I'm speaking and I'm collecting now feedback to see what's on the theoretical level input, and from the cities, it's too new. They just got the reports.
Well, from our side, we just found the flaws in the designs. Like they made, one example, they made a street revamped new, and they gave a traditional engineering firm the contract to count. Well, when did they count? It was in January, in the peak hour, 5 to 6. Well, my results show that peak hours are also, or not mine, our results show that peak hours are often at between 5 and 6, but not in the middle of the city. And so what they did was they had that count in January. Of course, the highest number in the inner city is at noon and not between 5 and 6. And then in January, it's a little bit lower than in the rest of the year. That's what we account for in our equation. And plus, in the wintertime, there was nobody sitting outside. So based on the result from that traditional count of that firm, they designed that space, and there was they revamped it and made a sidewalk and a little bit a larger sidewalk, which was okay. but it was way too narrow because in the summertime they put the tables out, they had vehicles parked because there were hardly any cyclists in January, but in the summer there were lots of cyclists. There was people standing, there were people using the restaurant, enjoying themselves on that street, and there were more people at noon. So there was a huge jam in a newly set up setting. So learning, understanding when the peak hour is, learning when to count and how to extrapolate the factors is highly important, I think, for the general. So far, I don't know what the impact is if people are actually using. These results are very new. We've just published that. But hopefully it will help these traditional firms. I don't mean to be negative, but these people who have designed or counted for half of their lifetime with the cars in mind should maybe be aware now how to count for pedestrians.
And I would also suggest to look for, there are some examples of the application of counting and tracking for tactical urbanism application, which are experiment by definition. So this kind of techniques is really useful to, let's say, to have an ongoing iterative approach for the design of the layout. So if there are some, errors or mistake in the layout due to the, let's say, the approach by itself of tactical urbanism, is very useful to use these evidences to. I think we have to close the session. We are pretty much late. And thank you all, but first thank you the speakers. It was really, really, really good to have you here.
Well, thank you. Thank you.